Hello, my lovely students. Your Anubha Ma'am is back with one more amazing session of carbon and its compounds, and this is session number 2. I hope you have watched session number 1 already. If you haven't watched it, please see it after this video. So what are we going to discuss in this session, everyone? We will talk about that why carbon is so special that it can make millions of carbon compounds. It's like 10 millions and still counting. So we'll still talk about that in detail. Stay with me till the end. Ma'am will talk about different form of carbon as well. So your Anubha Ma'am welcoming you here, students, and let's start it. Let's make it a big hit. I hope you're not feeling anxious at all. We still have so much of time to cover everything, and ma'am will make sure at least chemistry portion you will not even left with a single question, and you will be able to prepare it thoroughly and properly with all the type of questions. So are you all with me? Please like, share and subscribe to this channel and make it a big hit as well, students. And for all the newcomers, if you are facing so many problems like this, ma'am will tell you that all of your problems can be solved. Like if your doubts are not getting solved instantly and those are still there in your mind and you feel so confused what to do for the same, all of your doubts can be solved with the help of master teachers and a set of class teachers, chemistry experts on Vedantu platform, which is totally dedicated to help you out in all the sessions. Notes of every session so that you are like not going to waste your time in writing and not able to utilize it properly with all the important questions of a particular chapter. Test in every 15 days, assignments also, students, so that you'll be able to do all the twisted kind of a questions, so that in exam you are not like this question I haven't heard of. You will be able to get it properly because you have done enough practice. Competitive exams preparation, like side by side, if you want to prepare for JEE, NEET, Olympiad, everything is possible here. And the next part is schedule. It's like you can choose your own schedule. You can manage your classes properly with the choice of language, that is Hindi, English or English. We have batches specific to these languages also, so that you won't face any problem. And with so much of bonuses, like you'll be able to attend unlimited sessions in a day. It's all up to you how many sessions you want to attend in a day, so that you'll be able to manage your study accordingly, that how you want to prepare. With all the micro courses, chapter based courses, if you want to revise a chapter 100 times, that's also possible, but I'll make sure that you do not need that. If you study a chapter once or twice, you'll be able to get through all the topic properly and all of your doubts can be cleared. Yeah, performance reports in every session with the help of quizzes, amazing quizzes, leaderboard in every session, so that we'll make sure that you're doing good. Personalized attention of teachers, class teachers as well as master teachers. This is going to be a very awesome journey. It is like an opportunity, so please do not miss it. There is a link given in description box pinned by Vedantu 19 channel, and in that you can find a column where it's written get a pro subscription of Vedantu, and you can choose from 1, 3 and 6 months model. All are equally best, but if you'll ask me personally, right now what will be suitable the most is 3 months, because 6 months we might not have that, and 1 month is very short duration of time to get through everything. Alright, so do not forget to apply this coupon code AGEPRO, because that will help you to get discount from 20 to 43% on MRP. AG ma'am's code is AGEPRO. AGEPRO, do not forget it. And let's move ahead without any further ado. We'll talk about versatile nature of carbon, why carbon is so important, and all the allotropes of carbon, like different form of carbon that we have. So let's start, everyone. Give me a quick high five. Ma'am, we're super ready and excited. Let's begin the journey, students. Let's begin it right now with allotropes of carbon. First of all, what exactly is allotrope, students? Whenever you have an element present in different physical form, means different structure they are going to have, these are different form of the same element and are known as allotrope. Allotrope is like same element we have in different physical structure, so have their different names, but the substance is still same. So in the case of carbon, we have allotrope like diamond and graphite. These are the natural ones nature gave us, and when I talk about Buckminsterfullerene, that's the one that was prepared in laboratory by American scientists. Alright, these are the three that's there in your syllabus, though there are more allotropes also possible. And it's not like allotrope is limited to carbon. There are other elements that can also have allotropes. So I really want you to be curious, search it out and study about it, and do let me know in the comment section what two example of the other elements having allotropes, and give the names of allotropes also, at least 1 to 2. Two elements having allotropes and the name of allotropes also, at least 2. Alright, I hope you're clear with the question. Let's talk about the best friend of so many people, that's diamond. Oh yeah, diamond is so, we're crazy about it, some of them, not everyone. Why so? Because that's kind of very rare kind of a thing, very expensive and shiny. So what exactly this is? What if I tell you this is just carbon? Yeah, this is just carbon, made up of only carbon with some specific kind of three-dimensional structure in such a way that this is the hardest natural substance, and very high melting and boiling point, because the structure in which carbon and carbon is going to combine is very hard and rigid because of a strong covalent bonding that's formed in between. And what exactly this? Look at this, how carbon, when I talk about these circles, that's representing nothing but carbon. So carbon, there must be like representing in such a way that one carbon combined with 4 carbon in such a way that they make a tetrahedron structure. Tetrahedron is always a three-dimensional structure, not like I can draw in a plane of paper. If I try, like I'm doing it in the screen also, I'm not getting the proper picture. Look at this structure, this is more of three-dimensional, and you see it, how one carbon is attaching to 4 other carbon, you can see that. Three-dimensional, okay? You might have seen in so many Bollywood, Hollywood movies, they holding a big diamond and something looks like this, yeah? That's a tetrahedron structure where every carbon is going to attach with each other with very strong kind of force of attraction. All of these bonding, this is like a structure that's continuous, n number of carbon atoms attaching to each other. And what kind of a force of attraction? This is like a bigger picture as if we are looking at in a microscope, but these kind of bonds are very close to each other, and this carbon overlapping with each other by making very strong covalent bond, very strong covalent bonding. And due to this three-dimensional, very rigid, very strong covalent bonding, they are very hard, they are having very high melting and boiling point, because to overcome this force of attraction, we will be needing high temperature. Alright, and apart from that, they have high density too, because of having a very compact structure as well. Alright students, what else I can tell you about diamond, that why that appears to be shiny though it's not lustrous at all. The reason behind this, that diamond appears shiny, is not that it's lustrous, but due to internal refraction. Okay, so it's like when light enters into it, light will bend so much because of its structure, and when it finally passes to the air, like it enters from the air to the diamond, and finally from the diamond it will go again to the air, it bends a lot, and due to this bending it appears to to be glittery, to be shiny. This is due to this refraction, I think in physics. So strong three-dimensional network form due to covalent bonding, strong covalent bonding, and that's why very hard and rigid, and having a melting point around 4000 degrees Celsius around, because of strong kind of overlap between the different carbon atoms. High density, as they are very densely and closely packed, and as no carbon is free, every carbon having 4 valence electron, utilizing all of its valence electron and making bond. So carbon has no free electron, so it is not a conductor of electricity at all, but that's a conductor of heat though. Alright, do remember that. When I talk about graphite students, what is graphite and how that's different from diamond having only carbon? Because here the arrangement of carbon is different in such a way that it will act as a good conductor of electricity too. Let me discuss the structure. This is exactly the structure of graphite. These dots, these circles are representing nothing but carbon. Carbon attached with other carbon in making hexagonal rings, and that too two-dimensional flat layers, 2D layers. That is something that I can draw in a plane of paper as if you are holding a piece of paper. And suppose these kind of papers you're stacking one over the other. Okay, in such a way graphite structure will be there. Suppose you have this two-dimensional flat hexagonal layer, there will be one more, there will be one more. So many hexagonal flat layers are going to stack over each other, and you can see that also. And there is no particular force of attraction between these kind of layers. It's a very weak force of attraction that's holding them together, and that force of attraction is called as van der Waal force of attraction. Van der Waal is the name of a scientist. Van der Waal is telling that's a kind of non-bonding force, very weak kind of a force which is holding them together, because that's kind of necessary. And due to this weak forces, they kind of slippery into nature, very soft, and that's how act as lubricant also. Very soft and slippery due to this weak force of attraction, and very soft in nature as well. But these kind of a bond between carbon and carbon is very, very strong covalent bonding, and hence they have high density, high melting and boiling point also. Apart from that, not a good conductor, it's a good conductor of electricity, because every carbon here is making 3 bonds. Carbon has 4 valence electron, 3 valence electron is involved in making bond, making hexagonal rings. 1 of electron at every carbon is somewhat free, and due to free electrons, they are conductor of electricity. And students, you know, the single flat 2D layer is called as graphene. What do we call it? Graphene. And it's very strong because all of the bonding between carbon is strong covalent bonding, so very strong it is. Alright. Soft in nature, slippery in nature, comparatively low density than diamond, but yeah, having good density. And when I talk about having free electron that can conduct electricity, it has layered structure as well, and these are the layer of what? Graphene. I told you a single layer is called as graphene. Very strong, stronger than diamond too, but then it won't be natural because we have to extract it due to all the human efforts in laboratory. Alright, and very, very light in nature. Very important thing ma'am told you. Let's talk about one more form of carbon. This is the one that's very interesting to know, because that was formed by 3 American scientists in laboratory, and they were like, they had this kind of a structure, very limited number of carbon atom, that's 60 carbon atom attaching with each other, making a soccer ball, making a football kind of a structure. And then these were like, what will be the name of the substance? And then at the same time, there was an architect, and his name was Buckminsterfullerene. So Buckminsterfullerene represented a building model like in front of you, and he's like, that's so amazing, and this is like a new era, new kind of a building I'm going to draw. And these scientists were like, let's contribute the name on his building design, on his name. So he gave the name to his allotrope, their allotrope, as Buckminsterfullerene. Okay, Buckminsterfullerene. 60 carbon atom attached to each other. 60 carbon atom attached to each other. In what way? That 12 pentagons will be there, and just a second, 20 hexagons will be there. You're like, ma'am, how come 60? They'll arrange in such a way. Alright, it's like having one pentagon, and on its corner there will be regular hexagon, and then regular hexagon, and this is like keep on repeating. Pentagon, then hexagon, then again pentagon, then hexagon, 12 pentagon, 20 hexagon. The total number of carbon that's going to involve is 60. Limited number of carbon atom, so strong force of attraction is still there, but due to limited number of carbon atom, it's not going to be very strong, it's not going to be very soft. It's like okay, grayish color, blackish color substance, and acting as a semiconductor. Okay, it's like not going to conduct electricity at the room temperature, but at high temperature, and due to mixing of other special substances into it, they can conduct electricity. Alright, that's not that much there in detail in your syllabus though, but I have explained all the important part from which question can come to you. Now the point is, we ourselves are made up of carbon atoms, and you will agree with me. Yeah, it's like our body is made up of around 18 to 20% carbon. That means we all are carbon based students. Life on earth is carbon based. The CO2 that we are releasing is used by plants to make their own food. So plants is there because of carbon. We all are there because of carbon. And carbon is something that's responsible for almost all the things around us, living, also non-living. So right now, when the previous study was showing 3 million carbon compounds are there, now it's increasing and increasing. One study was showing 10 millions and more. So why carbon is so special that it's making these millions of compounds with itself and two other atoms? What so special carbon is having? Yeah, so carbon, let's talk about what are the properties that my carbon is going to have with me. Let's start it. These are the complete list that you should know. The very first one is catenation, that's called as self-linking property. Self-linking property means how carbon can combine with itself to make a long carbon chain in a straight chain manner, in a branch chain manner, where some of the carbon is acting as a branch to my main parent chain. It's like a tree having some branches. So it's like a main carbon chain having some carbon as a branches, and cyclic carbon chain where all of the carbon is connected to each other in a cyclic manner, not having free end, like making a triangle, rectangle, pentagon and all. Okay. Second is tetravalency. Tetravalency is carbon showing 4 valency, and because of the same, it can attach with itself by making different kind of a bond like single, double and triple. Also can connect with the different atom, maybe monovalent, maybe divalent and so on. And that's all the properties that we should know. And this question is very much important for exam, that why carbon is so versatile. They can ask in 3 marks, 2 marks. So catenation, I hope you got to know the self-linking property of an atom to make chains and rings. That's possible, as I told you. That could be like a long straight chain of carbon, and like branch chain, some of carbon is like in a straight chain, some is acting as like this branching, and some like connected in a cyclic manner like this. Suppose I drew a pentagon. This is not just pentagon, I wrote all the carbon in a cyclic chain. Okay, so this is what some of the possibility that we have. Straight chain compounds, branch chain compounds, where some of the carbon is going to attach in, obviously in what form, that carbon will be accompanied generally by hydrogen. Okay, these are the hydrocarbons we need to study in detail. So there will be a long chain of carbon and the valency is satisfied with hydrogen too. Okay, and then ring chain, where carbon is making a ring attaching to each other, and we use cyclo in the very starting in such compounds. So carbon has this catenation. Generally no other compound can show, no other element can show such catenation property. If I talk about silicon, that's limited to 8 to 10 silicon atoms, to be very honest. If I talk about sulfur, 8 atoms of sulfur can attach with each other, not more. Because why carbon is so the one that's showing these many compounds? Because of its small size too. Because of its small size, it can attach with the other carbon atom. Due to its small size, configuration is 2,4. Due to its small size, it can connect with the other carbon atom very strongly. Overlapping will be very strong. So we will get strong and stable covalent bond. Strong and stable covalent bonds. Alright students, and because of the same, carbon is the one that can make millions of compounds. Small size, good overlapping, strong covalent bond. Silicon belong to the same family of carbon but having 3 shells. 284 is the configuration. More and more number of shells, more and more will be size. More size, less overlapping, less strong covalent bond will be there. Okay. Second property will be after catenation is tetravalency, that how carbon showing a valency of 4 is responsible to attach with different atoms as well as same atom. Alright, and why this carbon is showing valency 4? Because 4 electron it will share with the other atom to have a noble gas configuration. All right, the configuration is going to become 2,8 by sharing of 4 electron, and that's the configuration of neon reaching to the noble gas configuration to give stable configuration. Now, when I talk about nature of covalent bond, I think we are very clear about the same. Thus, this carbon-carbon makes strong and stable covalent kind of a bonding due to its small size and having this possibility to make large number of compounds. Okay, so I hope very much clear with the same, that why carbon makes strong compound. Due to its small size, good overlapping, and going to attract the upcoming atoms or elements in a very with a very strong force of attraction. Okay, so this is something that you should know, and it can form single, double and triple kind of a bonding with itself. Carbon can combine with itself by making long chain with a single, double and triple bonding, obviously with hydrogen, and these are the different category of hydrocarbons we are going to get. Also one of the property responsible for the same. So students, what do we get to know about catenation? That's self-linking property due to its tetravalency, and one of the things that's including in the same is small size of the carbon atom, which is responsible by making these kind of a structure and having this multiple bond formation, single, double and triple. So this is something that's very important. You all should know it in detail. It's a very important question. So I hope whole lecture is super duper clear. Nothing difficult we discussed, but everything was so important for you to know. Now it's the time to do your homework, students. So please do let me know which properties of carbon are responsible for the formation of huge number of compounds. I've explained it. I am waiting for your response. Do let me know in the comment section that everything is clear. How was the session? And please do submit your homework so that I'll get to know that you're doing it properly. So this session done. In the next session, we'll talk about hydrocarbons and homologous series in detail too. So be ready for the same and keep following. Select your Vedantu Pro subscription by going to the link given by Vedantu 19 channel in the description box, and there select your grade and then select your target, that's CBSE, and get your subscription for 1 month, 3 months and 6 months. As ma'am told you, for 1 month you can save 20%, 31%, 6 months 43%. But do not forget to apply the coupon code AG, ma'am's code AGEPRO, then only you'll be able to get this discount. As I told you, this one will be the best one at this moment of time because of the time duration that we are left with, and you will be able to come out with better results and will be able to understand everything properly. So please do follow it. I hope everything is clear. Hope to see you soon in all the sessions. Keep following, keep loving, keep preparing. Happy learning, students. Thank you so much.